SAE benchmark.
On the reconstruction, and maybe this is out of scope, but have you tried at all, like using ITDA as an initialization of an SAE or whatever, and then train from there normally? Like, would you expect that to work at all, or not really?
I've not tried that. I also don't know if it'd work. No idea. It could do, maybe. I don't
Okay.
know how I would. Yeah, I have no idea whether that would work. Basically.
Okay, yeah. Someone in the chat asked, well, they're still writing, so maybe we'll wait for them to finish writing and you can move on and we'll interrupt you.
Okay. So then the other thing you can do with it is that you can't do with SAEs. It's just
Okay,
like,
wait. Sorry, they just finished. How do you capture higher order concepts that the module presumably learns through training? Well, I'll let him reply. How do you capture higher order concepts that the model presumably sorry, I'm having a hard time reading this word. Presumably learns through training.
So these concepts are captured in the activations that we construct the dictionary from. If that makes sense. So they're just already in the activations. Does that kind of answer the question?
They added is the dictionary not the model tokenizer?
The dictionary is activations from the model. So not the embeddings of the tokens, but the activations at a deeper point within the model. So, for example, with GPT-2, we used like the post-layer rate residual stream activations.
Yeah, they said that they understand now.
Cool. Yeah. So the other nice thing you can do with it is that because you can like reason about their dictionary in terms of prompts and token indices, rather than just like these unprivileged vectors, which is what you get with sparse autoencoders. You can directly compare the dictionaries that are learned on different models. So what you can do is, so all of your dictionary is like, I don't know, prompt 8005, and then your token is like token index 7, and then you can just like do equality comparisons between that, which lets you check on similarity set of prompt and token indices in the dictionary. And because there's no alignment here, that lets you do really fast comparisons between your dictionaries. So one way, like model similarity, well, I guess activation-space similarity metrics can be evaluated, which was introduced in the CKA paper, Center to Kernel Alignment paper, is that you can do this layer matching task where basically you look at the activations after every layer in 5 different models, and the task is, given that each layer should be doing doing similar things in each of the models, how well can you match the layers using representation and similarity metrics? So the similarity metric should be highest for the matching layer in the different models. So layer 8 in model 1 should match layer 8 in model 2. And these are like the same model architecture, same trained on the same data, just using different initializations. So this is GPT-2 small, that's pictured here. And the brighter the color, the more similar, the higher the similarity score, the average similarity score between all pairs of models is for each pair of layers. So these are two of the classical methods here, SVCCA and linear CKA, and they do like okay, and then there's a relative metric a relative representation similarity metric introduced by Marcella that does slightly better, and then ITDA actually gets the best performance on this evaluation just by doing the Jacquard similarity of dictionaries trained on each of the layers on each of the models. And this holds up for different models as well, not just this set. So you get state-of-the-art performance against all the different methods I tested on this. And this lets you do nice stuff like I looked at layer convergence in the Pythia suite of models and reproduced an early result that the similarity between layers at different checkpoints goes up faster and earlier for early layers. So like it's like layer 2 or something. No, probably layer 1, and that converges earlier than layer 2 converges earlier than all of the subsequent layers. And you can see this like nice pattern emerge where as you go through bigger models that you start converging earlier and earlier. And then by taking the union of your ITDA dictionaries, you can do across all the layers of your model. You can do like model-wise diffing. So this is a similar experiment to the layer diffing one, where we have 5 different initializations of GPT-2, small, and 5 for medium. And then this guy is just like the similarity between the dictionaries of each of those different initializations. And we see that it can always classify like which model is the same model. Sorry, that yeah, obviously can do that. Sorry, but the score between the smalls is much higher than score between the medium, and then there's like lower scores here. So you can like do whole cross model comparisons using the union of the layer-wise dictionaries.
So in this picture, if you had a randomly initialized model, would the Jacquard similarity, would you expect it to be like 0? So what's the baseline for like non-alignment at all in this experiment?
Yeah, that's a good question. Would it be 0? I think it would not be 0 because for any model, it'll probably just select like a bunch of the first tokens that it sees. Like it'll always definitely select the first activation it sees to be in the dictionary. Because the dictionary is empty, so it can't reconstruct it. So then definitely at least the first activation would always be in the dictionary, so it would be non-zero.
Okay, so in these experiments, you're always, the data is always the data where you train the dictionary is the same.
Yes, yeah. So that's one of the, I guess, fundamental limitations of this is that you need like an ordered data set to do any kind of comparison.
Yeah, I meant to ask exactly that. Like, I'm assuming that, especially for these, like shuffling activations, feels more important than in SAEs, just in the sense that otherwise you'll get a lot of your dictionary entries will be correlated or something. Do you expect that as well, or I don't know if you explore that in the paper, that that shuffling matters a lot.
So yeah, if you shuffle the activations, you get very different dictionaries.
Yeah.
Because of this like bias towards selecting early activations during training.
But do you get better performing dictionaries if you shuffle versus not shuffling, or?
No, I did.
Okay.
I didn't shuffle.
Okay.
You can probably like So it's one of the like future directions that I mentioned here that like I think the quality of the dictionary is probably very susceptible to data ordering. In particular, like so shuffling, but also going like iterating first by index and then by prompt versus first by prompt and then by token index. So doing like prompt 0, prompt 1, prompt 2, 0, 0, 0 versus doing all the tokens in a prompt. I think stuff like that is going to be really important to the editor performance. but I didn't really explore this. Cool. So the advantages to ITDAs, they're trained on like all of the ITDAs were trained on 1 million tokens, which is quite a few less than SEs are normally trained on. So Gemscope was in 16 billion. The GPT-2 SAs we use in the canonical units paper were trained on 300 million tokens. ITDA itself is like slower to evaluate than SAEs because it's doing this like complex inference-time optimization rather than just like a linear forward pass. But because it's it's trained on so many fewer tokens, it's a lot faster to train. So depending on like the balance between your inference use of the SAE and like the training cost of the SAE, it just can be a lot cheaper to train and use. And I think the other advantage is like it seems like it's fairly nice properties for model diffing, like directed research. But again, that's not something I explored. Well, except these activation space results. Drawbacks are, I found it to have it does to have like worse performance in benchmark results than sparse autoencoders. Stefan Shablin had this paper about evaluating SAEs and ITDAs on diffusion models, and he had more positive results. And says that the paper says that ITDAs are like similarly interpretable to sparse autoencoders. That's not what I found, but it's reassuring that he had better results on that. I think, yeah, there's in terms of doing like ambitious activation decomposition, which is like I guess what SE started out attempting to do. Like ITDAs definitely don't do this. So they don't find the ground truth features that the models are using because they're just using activations as their decoder. It's possible that SEs can like find these directions, but I'm like a bit skeptical of this. Maybe there's like future variants that will be better at this. And then the other drawback is like you have to use the same training data in the same order to do any kind of comparisons between the dictionaries. And in terms of future directions, I think like exploring model diffing a bit more, and particularly just like this dictionary intersection operation, or like dictionary diffing operation. Does that carry semantically meaningful information about the model? Like it definitely carries this like some information about differences in the models because we can do this. But can you actually just like look at the differences in the prompts and tokens that the different dictionaries have learned and read off the different functionality the models will have? And also like just because they're so cheap to train, can you do kind of monitoring of models during training? Stuff like this that you probably can't afford to do with sparse autoencoders because you'd have to pause your training for like days every time we would come up with SAEs. I think it'd be interesting to like apply ITDAs as cross-coders and transcoders. Somebody was doing that in Neel's training phase, but I don't think they got very far with it. Different ways to construct the dictionary. So, like you said, data ordering. Like Adam said, adding bias terms to the training. And also just like alternatives to Matching Pursuit. I tried a few different ones, and Matching Pursuit was like the most performant whilst maintaining like a reasonable optimization cost. But there's probably better algorithms that can be used in it. Cool. That's the end of the presentation.
John, do you want to say your question out loud, or do you want me to? John asked in the previous slide, what's the difference between the 5 measurements of a single model? In the slide where you have GPT small and medium, yeah, those 5. What's the difference between them?
Yeah, so there are 5 different initializations of each of the 2 models. So there are like 5 different training runs for GPT-2 small and GPT-2 medium.
Five different seeds of the dictionary.
No,
of,
five different
of,
LLMs.
okay.
So it's GPT-2 small, retrained from scratch 5 different times.
Right.
The for ordered data, the training is deterministic of iters, so you always get the same dictionary.
That's one question that I have for you. Like, do you envision, or is there any, I don't know, in the literature, any way to do this, of somehow reusing the latents? I mean, replacing them, because like as you're training the dictionary, it grows, and maybe for a fair comparison with an SAE, you stop when the dictionary is the same size, but maybe you could still get some improvement if you were able to remove, let's say, some stale directions or stale activations with some better activations or whatever.
Absolutely. So like
Is there any way to do that?
recycling dead latents. I looked at very briefly. You do get like a reasonable number of very infrequently activated latents. And there's probably ways that you could like remove them, continue training for a bit, and get better dictionaries. Yeah.
Yeah, I think Stepan and I'm not. I think he tried some about dead latents as well. I think he tried transcoders as well, but it wasn't. Yeah, we were not never beating SAEs. Sorry, not never beating the baseline uh, by that much by anything. So, but I'm not sure. I think he tried, but I can't exactly remember.
What was the baseline for transcoders?
Well, yeah, we were training our own skip transcoders, and then uh, using ITDA and trying to beat that baseline. I think, if I remember correctly, at that time it was on Pythia or on GPT-2. I'm pretty sure we still hadn't started doing the experiments on small, so it was probably on Pythia. But we were trying to beat the skip transcoders.
Oh, I'd be super surprised if you beat skip transcoders.
Yeah, we didn't, and then we stopped, and we all we started this because I thought it was a cool idea, and but then Stepan said that you were working on it, and so we were just waiting for you to finish, let's say, and then see if there was any interesting stuff to continue doing afterwards.
Okay.
Are you still planning on continuing on this, or are you just moving on?
I'm currently just moving on. So yeah, I'm not currently working on anything related. I think like I might revisit model diffing with it at some point. I played around with it a bit before and was like I think I don't know. Model diffing is such like a nebulous problem that I think I couldn't pin down exactly what I wanted to achieve with model diffing, so I didn't look into it further, and then other stuff came up as well. But I think there's potentially interesting questions. I don't know.
I see that there was someone writing a question, but then they stopped. I don't know. I'm waiting. You
Yeah,
can
I
ask.
wasn't sure if it is. So, I mean, I think like in the first slide, like one of the motivations, let me just ask it anyway. So, I think one of the motivations, one of the ways we motivated was that, SAE latents are weird and, um, yeah, I mean, they don't give us the right units of analysis always. And I'm not sure, like, I mean, like after trying this method, I get the sense that you don't really think this also gives the right unit of analysis. So I was just curious, like, I mean, is that correct, my understanding? And B, I mean, are there other directions you find interesting for finding the right units of analysis?
Yeah, so I think like activations are kind of a good unit of analysis, but they're quite hard to use for analysis because they're like so composed of different things. What it does with them, because it's doing this inference-time optimization, is you get like virtual features where, depending on like the order it decomposes things, you can think of having like each latent has it's used differently at different times, and it's not like super easy to read off the direction or anything from the decoder. And it's definitely not like, ideally SAEs would learn in the decoder, they'd be like a direction for whatever concept you're interested in, and you should literally read off that direction, which it don't give you. In terms of better approaches for finding the correct units of analysis, I don't know. I'm pretty conflicted on this. I think like the essays definitely for me aren't doing it at the moment. I'm not sure how. I think sparsity is such like a optimizing for sparsity gives you really weird stuff, and I think I don't really see how that can be fixed. And I do kind of support the pragmatic Mech Interp thing where you just like try a bunch of different things and see what works for your task. But yeah, I don't know. This one I think about this quite a bit, and I'm not really sure what my stance is on it at the moment.
Okay, yeah, thanks.
That was a terrible answer, but
No. I just curious. Yeah, thank you.
cool.
I mean, can I ask you a bit more on this last thing that you said of sparsity? Do you really? To me, it always felt that sparsity was like a good like proxy in terms of interpretability, just because yeah, it's hard for us to keep in mind like a concept if it's not a concrete, like a sparse thing, like if it's something that's ever present and distinguishable from one example to the other, it's probably hard to understand it. Do you think that like just, or I mean not just, but the thing that makes you think that sparsity is cursed is this idea of feature splitting and absorption and like the wedging thing, or do you think that like even if we somehow fix those, other problems will appear just because sparsity is not really what we should be aiming for?
So to clarify, I have an issue with optimizing sparsity, not sparsity in itself. I think like you can represent you can represent the world with sparsely activating features, and it seems like models are definitely doing some kind of, they definitely have sparse features because there are some monosemantic sparse neurons. It looks like you can have virtual neurons that sparsely activate. But I think the issue arises when you start applying an optimization pressure to sparsity. And that's when you get issues like feature splitting and absorption. But sparsity in itself, fine. But when it's the optimization pressure for sparsity that I think is causing the issue. Does that make sense?
Yeah.
Cool.
Yeah. So if we somehow could get sparsity for free, that would be something that you'd be more interested on instead of having to optimize for sparsity.
Yeah, exactly. Yes. When you optimize for sparsity, like it introduces feature splitting and that kind of issue. And if you knew the correct, like, if you knew the number of features that you were supposed to use to reconstruct each signal, then I think we would be able to find the, like, maybe not the ideal set of features, but a good set of features, and maybe the perfect set of features. But because we don't know that, and we're just like optimizing for it, I don't think we do get it. But yeah, if sparsity was for free, I think we'd have a much better chance of finding the ground truth features.
Yeah, I guess if other people don't have questions, we were a bit early, but I think going like this to the paper is better than just dawdling around, seeing everything. You have the last 30 seconds to ask a question, otherwise Patrick is probably wants to go.
No, there's no rush, but go on.
So you did mention using the Jakarta index for what was it called? Identifying similar models. Do you understand why? Do you have any insights on why ITDA might be particularly, or is that deferred to future work?
Sorry, you broke up a bit there. Could you repeat the question?
Basically, you mentioned that it outperforms other methods in terms of identifying a model, if that makes sense. So, do you have any insights on why that happens, or is that just deferred to future work?
I do not know why that happens. Yeah.
Right.
Yeah, I was quite surprised that it actually did perform so well on this. And I did not investigate very much why it does so. Cool. Are there any more questions, or do we wrap up?
Yeah, I would say if there's no more questions, thank you for coming. Sorry for the misschedule thing.
No, all good. Thanks all for coming and asking such good questions.
See you next time. Bye, everyone.
Bye.
Noura.